I just got my new computer up and running. It's stable, but I'm still optimizing a few things. I want to take some time today to talk about overclocking. This will be more of a why-to guide than a how-to guide. What's important to understand is that every chip's a little bit different. There's material and manufacturing variations that affect the performance characteristics of the electronic components that you buy. Sometimes online you hear people refer to this as the silicon lottery. Additionally, manufacturers bin or separate their components based on how well they perform in their tests, so they can sell the higher performers at a higher price. This happens for all sorts of components, from resistors, capacitors, to complex system-on-chip products like processors or graphics cards. During manufacturing, all these components get tested prior to shipping. For complex parts, that can be configured multiple ways, like your CPU or graphics card. The manufacturer chooses a preset for settings that they think will work for most people. They design their testing around that set of assumptions and typically run tests that are a little more stressful than the operating conditions they expect them to run at. This ensures a high product reliability, but they have to balance this extra margin that they get with their manufacturing yields. Now, microelectronics manufacturers have other tools that they can use to maximize their yield and reliability, like high temperature burn-in or overvoltage stress tests, but we're not going to get into those today. Back to the silicon lottery. Remember that all chip manufacturers have to choose presets that are going to work across all of their use case and product variability. So the settings that they choose are applied in a more general use and not optimized for your specific chip or use case. Depending on where you fall in the silicon lottery, the presets your chip ships with can be anywhere from really close to way off from the optimal settings for your specific processor, graphics card, memory module, or whatever else it is. So this is where overclocking comes in. Overclocking is just a general term that means tweaking the settings that were preset by the manufacturer to optimize your chip for your specific product and use case. Maybe you want to run your hardware at a higher clock speed and voltage because you can dissipate more heat than the average user, or maybe you're willing to accept more risk for component damage or reduce life for your components than the manufacturer was. The point is that overclocking allows you to tailor your hardware to do exactly what you need it to within the bounds of your system's capability. On this latest set of Ryzen CPUs, undervolting seems to be a great way to get additional performance out of your chip. By lowering the voltage that the CPU runs at, you decrease the amount of heat created, which lets your CPU run higher workloads for longer periods of time. It also decreases the waste heat created by your system. When you decrease your voltage, this comes at a cost of clock speed, and the trick is to balance the amount of heat you create, because it all has to be removed by your cooling system, with your core speeds. It takes some trial and error to find the best settings, but once you get it right, it can make a really big difference in terms of performance, efficiency, and computer noise levels. If you like tinkering and optimizing this kind of stuff, give it a try. If this is your first time and you have a Ryzen CPU, try using the Precision Boost Overclock or whatever other automated overclocking tools come with your setup to make it easier on yourself. If you're feeling more adventurous, try playing with some of the manual settings. Just keep in mind that if you push something too far, you can damage your system, so make sure you do your research first and keep a close eye on your thermals and power consumption while testing. Overclocking a CPU is just the start. There's also your graphics card, memory, peripherals. One thing I've learned, there's diminishing returns with how much time you spend optimizing your system. Once you're in the ballpark and have a stable setup, all those hours spent pulling out another 1% to 2% performance could probably be spent better somewhere else. Good practices for overclocking almost requires that you make small individual changes, testing in between each one so that you know how each change affects your computer. It can really suck up a lot of time. Alright, I'm filming this about a week after my initial testing. I'm pretty sure one of the VRMs was bad on the first motherboard and it wasn't delivering voltage properly, because 3 days after installing the system, the CPU temps would climb until they reached the thermal limit of the chip and just shut off the computer, even though it was idling. After both the ground loop and the VRM issues, I decided to send that motherboard back
and get a new one. Admittedly, the one I bought was pretty low quality. It was one of the cheapest ones I could find. So learn my lesson. Please learn from me. Don't buy the cheapest motherboard you can, especially if you plan on overclocking it.
With the stable motherboard in place, I ran my benchmarks and saw just over a 15% CPU score improvement. Then after I swapped the motherboard, I put an ECase 360 AIO, which gave me a lot more thermal headroom to start pushing the clock speeds. My performance improvement with the working motherboard and the bigger cooler were more modest compared to stock, only seeing about 8% improvement with the 13 degrees Celsius cost to thermals. I'm fine with that because it only brings my full load temperature up to about 70 C, and it seems like for these chips, and probably generally true, that tweaking your settings will net more gains in thermally constrained scenarios, since you can better control how the CPU performs at clock speeds much slower than it was designed to run at. This is especially true when your chip's performance is highly dependent on temperature and voltage like it is for these 3rd gen Ryzens. My new overclock looks like a more standard overclocking scenario, adding heat in exchange for performance, and playing around with the various overclocking options available. Most people will probably do just fine keeping their chip stock or using one of the built-in auto overclocking methods like Precision Boost, Overdrive, or whatever the equivalent is for Intel. You can pull out a few extra percents of performance by manually tweaking it, but it can take quite a bit of time to test. And this all requires that you have the cooling performance to support it. However, if you have poor cooling, you'll probably net a bigger performance gain by manually adjusting some settings, primarily your CPU core and voltage levels. Unless you're running a small form factor build, it's probably a better idea to just address your cooling issues. Overall, I'm pretty happy with the performance I ended up with, and I learned a lot about the behavior of these CPUs. I usually end up overclocking about half of my builds depending on the hardware and what I plan to use the system for. This one's my daily driver that I use for gaming and video editing, so it made sense to spend the time optimizing it. Thanks for watching. If you're interested, check out my video about my custom PC desk that I'm using to store all of my new hardware.